Hey guys, welcome back, and we're going to go over 7.3, which is classifying triangles. So, real quick, these are terms that you might have heard before, but there are three types of angles. We have an acute angle, which is an angle that is less than 90 degrees. We have a right angle, which is exactly 90 degrees, and we have an obtuse angle, which is greater than 90 degrees. And then just a quick recall, all triangles add up to 180 degrees. So all triangles are going to have three angles every single time, no matter what kind of triangle it is. It's gonna add up to 180 degrees. So, triangles can be classified in two ways, by their angles or by their sides. All triangles have at least two acute angles, but the third angle is used to classify the triangle. So, real quick, before I get onto this, all triangles have at least two acute angles. Now, why is that? Well, so there's three angles in total, right? So if we were to have less than two acute angles, that would mean that at least two of them are right angles or obtuse angles, right? 90 degrees or more. Well, what happens, right? If we have two angles that are at least 90 degrees, well, if I choose even the smallest one possible, right? Two non-acute angles, 90 degrees, that already adds to 180 degrees, right? So any other angle I put here goes past 180 degrees, right? That would make it 210 degrees. So you can't make a triangle out of these angles. So we need at least two acute angles, but then the third one determines what kind it is. So here's what you're really going to want to write down. Here are the four when you're classifying it by angles specifically. So we have an acute triangle, which means all the angles are acute. We have an equiangular triangle, which means all the triangles are the same, right? So that angle is equal to that angle is equal to that angle. And to be more specific, they're all 60 degrees, right? Because to add to 180, 60 plus 60 would be 120, plus 60 would be 180. So these are all 60 degrees. And an obtuse triangle is one that has one angle that is greater than 90 degrees. So that one right here looks like it's a little bit more than 90 degrees. And then a right triangle is one that has a right angle or a 90-degree angle in it, which is often denoted by the little square there. So classify each triangle as acute, equiangular, obtuse, or right. This one here, every single angle is less than 90 degrees, so that means it is an acute triangle. Now here, for this one, I don't even have to really think about the other ones. I see 90 degrees, and I immediately, as soon as I see 90 degrees, it doesn't even matter what the other two are, I know it's a right triangle. Now for these ones, again, as soon as I see 97 degrees, one angle that is greater than 90 degrees, that's an obtuse angle, so that means that this is going to be an obtuse triangle. Right, and then this one, all of them are 60 degrees, all of them are the same angle, or it's equiangular. So we have an equiangular triangle. So classify PQR as acute, equiangular, obtuse, or right, and explain your reasoning. So first things first, PQR, triangle PQR. There's kind of three triangles going on here, right? We have PQS, we have QSR. PQR is the big one that goes all the way around. It's this whole triangle here. That's PQR. Well, at first, you might want to say acute because you don't see any angles that are greater than 90 degrees, but this angle Q is this whole thing here, which is 45 degrees plus 59 degrees, which is 104, right? So since that's 104 degrees, that means this is going to be an obtuse triangle. since it has an angle that is greater than 90 degrees. There's also another way. We didn't even need these two, right? If it didn't give us these two, we know that a whole triangle has to add up to 180, right? Well, here we have 45 and 31. This whole angle better be 180 minus what these are together, right? So minus 45 minus 31, right? If a whole triangle needs 180 and we have 45 and 31, this angle has to be what makes 180, which if you do that, you will also get out to 104 degrees. So triangles can also be classified according to the number of congruent sides they have. So this time we're doing it by their sides instead of their angles. An equilateral triangle has 3 congruent sides, so that means all the sides are the same length. Now equilateral and equiangular are the same thing, right? If they all have the same side, they're all going to have the same angle, but it just depends, on what you're talking about, right? An isosceles triangle has at least 2 congruent sides, and I don't really even like this word at least. I just like 2 congruent sides. So isosceles triangle has 2 congruent sides. And we'll see these are the 2 ones that are the same here. Now a scalene triangle is one that has no congruent sides. So none of them are the same. And then just a quick another recall to indicate that sides of triangles are congruent, an equal number of hash marks is drawn on the corresponding sides. So what this means is I give this 1 hash mark, and then if I give any others 1 hash mark, that means they are congruent or the same length. So since I gave this one 2, this one, if I give this one 2, that means they're the same length. And then also, this also goes for equiangular too, but technically equiangular and equilateral triangles are acute triangles, right? But you want to be more specific if you can, and if they are equiangular, you want to say that. So I kind of missed that back there, but this should be fine. Now, a quick definition that I'm throwing in here because I don't think it's too big of a one to just kind of throw in the middle of the lesson. Midpoint is a point on a line segment that divides it into 2 equal parts. Now, that's a fancy way for saying it's in the middle of a line, right? So if I have a line segment, a midpoint, maybe M, is just right in the middle, right? And, kind of what follows from that is if that's right in the middle, then on each side, these 2 lengths better be the same, right? If I go from A to B or something, AM better be the same as MB, right? So if M is the midpoint of line segment JL, classify triangle JKM as equilateral, isosceles, or scalene. So I'm looking at triangle JKM, which is this one, right? And I know that it gave us this tick mark and this tick mark, or hash mark, to show that those sides are the same. But I also know that if M is the midpoint here of JL, right, then it cuts this side and this side into equal parts. So I know that all of those are the same. Now, if this whole length is 1.5, then this length here better be 0.75, right? Because the midpoint cuts it in half, so 1.5 cut in half is 0.75. Which, if you're thinking quarters, not a big deal, right? $1.50 cut in half is 75 cents. And so, since this tick mark is the same as this tick mark here, that means this is also 0.75. So we actually have an equilateral triangle here. Right, because all the sides of JKM are the same length. Now, let's do it to KML. Now, KML is going to be this triangle here, which we don't even have to do any work for this. I see a tick mark there and a tick mark there, and I know those are 0.75, that's 1.3. And so since two sides are the same, but not the third, that is going to be an isosceles triangle. And so for our last example here, find the measures of the sides of the isosceles triangle ABC. And so here we have these two tick marks informing us that these two sides are congruent or equal. And the other day I actually had a student say, how does that make sense? How can 4x plus 1 equal 5x minus 0.5? That doesn't make sense. And then I was like, hey, you're crazy because you just told me exactly what you have to do, right? You said that these two sides are equal, right? That's what those hash marks mean. So that means that 4x plus 1, I'll write this a little further down. That means that 4x plus 1 equals 5x minus 0.5. And I think once we see it written this way, it's a little more obvious, right? But before he was like, well, that doesn't make sense how 4x plus 1 could equal 5x minus 0.5 because they're different things, right? We'll set them equal to each other, right? Because they can equal each other. We just have to find the right x to make them do that, right? So now we just need to solve for x, get all the x's on one side and all the constants on another side. I'm going to subtract 4x from both sides. That way I keep my x positive on this side. 4x minus 4x cancels, and I'm left with 1. 5x minus 4x is $5, and I spend $4. I have $1 left, so 1x or just x, and then minus 0.5, and then I get rid of the 0.5. I'm going to add it over, and I'm going to be left with 1.5 equals x. And if I wanted to write it the other way, just so it looks nicer, x equals 1.5. And that's all we need to find all of these sides, right? So if this side is 4x plus 1, well, I just said that x is 1.5. So 4 times 1.5 plus 1. 4 times 1.5 is going to be 6, plus 1 is going to be 7. Now 5 times 1.5 minus 0.5. 5 times 1.5 is going to be 7.5 minus 0.5, which is going to be 7. So, and that makes sense, right? Both of these sides should be 7 since they're equal, right? And then this one up here, we have 9 times 1.5 minus 1. 9 times 1.5 is 13.5 minus 1 should be 12.5. And how I do the 1.5 in my head real quick is I say, okay, 1.5 means I'm taking a whole and a half of something. So what's half of 4? 2, right? But I'm getting a whole and a half. So a whole 4 is 4. Half of 4 is 2. Together that's 6. Plus 1 is 7. And I do that for all of them, right? What's half of 5? 2.5. So 5 plus 2.5 is 7.5 minus 0.5, right? What's half of 9? 4.5. So 9 plus 4.5 is 13.5 minus 1 is 12.5. But that should wrap it up for 7.3.